Everyone, today I'm gonna clarify a topic dedicated to straight lines or linear functions. So basically, straight line is just LOC. You know, this term from GCSE is just set of points, so that all the points line on one single line. That would means straight line, and that's what define LOCI. Okay, so because this is just visual presentation of the function, we need to say that the function should have the linear form ax plus b, for example. So that's general linear dependency. But normally for GCSE purposes, in many books you are explained like mx plus c. Actually, it doesn't matter which letters, which coefficient you will use, m or c, and versus a and b. It doesn't matter. So however, a general equation defines linear dependency y from x. That's why you have straight line, not the curve. Okay, so for our purposes, we'll be using the bottom one as the reference equation for the straight line. And now it's very time to understand how it works, what each coefficient m and c defines, what it's responsible for, and also we'll try to probably use an equation, try to build the line. Okay, let's get started. So first of all, I want to tell you that our basic line is just y equals x. So how to build the graph of this function? What we need to do. So you know from geometry, we need just to have 2 points in order to connect them with a single line. So that's why, for this reason, it's really enough to have 2 points. So every single point on Cartesian plane should have 2 coordinates, x and y. For example, any given point here, we have x and y coordinate. How to define? I'll help you remember. You just need to put 2 perpendicular until it will be intersection with x-axis and y-axis. And that exactly tells you the coordinates. For example, in this particular case, if we take the scale that one cell is just 1 unit and vertically the same, so we understand that it will have coordinates 4 for x and let's say 3.5 for y. Okay, that's how we can define the coordinates of the point. So for our purpose, to build the equation of this very simple and the basic line, y equals x, we just need to plug any value instead of x. Let's say, very convenient, of course, we can start from 0 in order to define y, so y is also 0, right? And we can plug, let's say, 1 to any just value. For example, 2, so that they be split apart. So y is also 2. So that's what is called identity line. Identity. Why? Because x value is equal to y value. Alright, let's build it up. So I raised just my previous line where I define LOC and also this point because I need space. So we have 2 points. The first point is 0, 0, and the second point is 2, 2. Alright, so let's put the first point and mark it with A, and the second point mark it with B. Alright, so the second is 2 and 2. So obviously it's here. So we connect those 2 points, and it will be an equation for the straight line y equals x, and this line will be here. Alright, so that's pretty straightforward. Why is identity? Because x value always corresponds to y, means it equal. So for example, if you take 1 for x, y also be 1. If it's 2, that will be 2. If you take negative value, let's say negative 1, it will be negative 1 for y. Okay, that's why it's called identity. So it's very time to have an understanding about the first coefficient m. In our case, when we consider the straight line y equals x and comparing with the general form, we understand that the first coefficient before x actually is 1, right? So in our case, c is 0, so we skip it for a while and be focused first of all on the very first coefficient m. Okay, so it's 1 in our case. But what if it's like 2 and 1 over 2? And what it's designed for? Okay, so just let's compare, for example, the second line with equation y equals 2x. Alright, so what's the difference? The difference is if you set up the table for this line, y equals 2x, it will give you the following values. You'll take the same points for x, so the same coordinates for x, 0 and 2, and let's see, according to the formula 2x, we need to double the value. So here is going to be 0, but for next y, you'll have 4. Alright, so that's why when x was 2, here, now a new value is 4, alright? So that's why instead of 2 for y, you'll have 4 here. Okay, so that's why the new point will be here. So the second point is in the origin, in 0, 0. Alright, and let's connect with blue. No, it's better to use green. Okay, let's connect those points with the green line. Alright, so we draw the line with the equation y equals 2x. And it's really the right time to understand the influence your coefficient m on how your curve, how your line behaves. So we understand that the more coefficient here in comparison with the previous line, the more I'm going to say that the steeper the line, all right? So it looks like it turned a little bit and becomes a bit steeper. So while here, there is another turn. So it turned in an anti-clockwise direction and it becomes steeper. All right, so it looks like m is really responsible for the angle your line has to horizontal x-axis. All right, so this is the way how we can describe the influence on the very first coefficient m. So it will define the angle, so where between the line and horizontal x-axis. So actually it also defines the angle between your line and y-axis, but normally for that's agreement of all mathematicians in the world that the line is defined relating to x direction. So basically we will use this angle, right, to the horizontal x-axis. So that's why m is responsible for this angle. Okay, but how to measure exactly? So we understand that there might be different coefficient m, right? But how exactly to say about the right influence? Because you can measure, of course, you can use your protractor, right? And in degrees, you can measure your angle for one line and for the same, but it's not practical. It's not practical at all. So how to understand how we can calculate this coefficient? So obviously it's pretty simple. So let's assume you have a straight line that goes, for example, that way. All right, and we would like to have, let's say, 2 points. Let's say that is going to be a starting point, and let's take point where it's like, so I'm going to say good point, say here. b. And let's have the coordinates. So 1, 0, because it's 1, right? One cell here. So let's say b would have, so 1, 2, 3, 4, 5, 6. 6 for x. And let's say 2, roughly 2. So we'll consider it as precise value. So 2 for y. Okay. Let's say we have those 2 points that lay on the line. And we have an equation y equals mx. So our purpose is to define for that line this coefficient. Okay, how we can calculate it? So basically we can use this triangle, right? We can use this triangle. Okay, and actually if you complete 2 equations, or just simply, let's say, yeah, it's better to use 2 equations because for our case, we need to have some c variable here, because I didn't tell you about c coefficients, but normally the equation should have like the first leading coefficient and the last one. So we don't care about the last one. We want to find the first one. Okay, what we can do in order to do that? So we can plug the coordinates of the point B, and at the last we can plug the coordinates for A in our equation. Why? Because both points lay on the graph. So that's why if we plug coordinates for B, we will have the following. So y is 2, right, equals 6m plus c. All right. So we can also plug A coordinates in our equation because it's also on the line. So we will have 0 equals 1m plus c. And now, because our goal is to find m, not c, we want to kill c and solve like simple simultaneous equations. Alright, so the best idea is to subtract and say we have 2 equals 6m minus m. That will lead to 5m. Alright, so we almost found it. And m is 2/5. Okay, so let's try to interpret this information. Actually, what we did, we subtract 2 points in our equation. And because we killed c, we actually subtract y coordinates, right, on the left side. So we subtract from 2, this y coordinate of b, we subtract which coordinates? Y coordinates of A. It's here. So basically, generally, we have change in y coordinates for 2 points. Okay? So what we'll have here on the right side, because C was killed or eliminated, we actually did the following. We subtract some 6m minus 1m, but what actually stays behind in general way? So there is mx, right? And m times x of the first coordinate, b, it's 6. We subtracted m times the second coordinate. Because m is the common factor when we're subtracting, we actually have the following, m and change in x, right? So those delta symbols are used as change in corresponding values. So here is change in y coordinates and here is change in x. So generally we understand that m coefficient turns out to be the ratio change in y over change in x. So basically it means that if we apply to this definition for this coefficient, we could say that no matter which points we take on the line, might be any random points, but they should be on the line with coordinates, let's say x1, y1, and b x2, y2, we can simply do the following. So if we have general equation of the line mx plus c, we can plug both coordinates and say that we will have two equations, mx2 plus c, and y1 is just mx1 plus c. All right, so in order to find m, we just need to solve simultaneous equation by elimination or using elimination methods. So we're actually subtracting, and we will have y2 minus y1 of the points. So on the right side, we will have m as common factor, x2 minus x1. All right. So from here, we can determine m as, again, change in coordinates for y and change in coordinates for, and change in coordinates for x, right? So that's why it's this, as we obtained. So basically, where you can find that if you want to see where exactly we have change in y and change in x, have a look back here, and here is going to be change in x. So that horizontal change, because you take an x2 and x1 and subtract. So that's why it will be this segment, and here actually will be change in y, right? So that's why m is change in y over change in x. But look indeed, so what we have here, if I erase those coordinates, what actually we have, and also erase b and transfer here, we have the following. We have a right angle triangle, right? And we have this leg to be delta y and this leg to be delta x. So what we can say, if we divide this leg over that leg, and so let's input some angle alpha. Let's remember trigonometry, because this is about trigonometry now. So trigonometry. So remember, trigonometry is about how two sides connect with the angle. So change in y is opposite relating to this angle. So this is opposite side. This is adjacent side. So if we take opposite over adjacent, what actually this stays for? It stays for tangent, right? If you remember trigonometry and definition for a tangent, this is exactly the tangent of this angle. So, and it turns out that coefficient m defines the tangent. So it exactly equals to the tangent of the line. And that's why, because here we actually revealed interrelation between alpha and coefficient m, we can go back to the very beginning where we just made an assumption about how your coefficient m connected with the angle. So yeah, we guessed that it defines the angle because we just plug the coordinates, right? Some points, and we actually calculate y for different lines with different coefficient m's. So that's why here we can exactly, we have to exactly say that m is exactly the tangent of alpha. You see how two topics dedicated to trigonometry, that's basically geometry, and straight line functions are connected. So in maths, actually, there are lots of different topics. They are interchanged, they are interrelated somehow, like in this case. Okay, so that's why, because m is connected with tangent, so m is called sometimes the slope, or it defines the slope, or gradient. Why it's gradient? Because it defines how fast your function is changing, all right? So it defines the change of y relating to change in x. Okay, so let's do a little recap. Let's summarize what actually we can do in order to define your gradient. So we need, if we have straight lines, so basically we need to take any points on the line in order to define the equation. I define the first coefficient m. So we need to take 2 random points, but I would like to use points that stay on the x-axis, and basically another point that we can clearly see the coordinates, right? For example, here we have 2 for y, right? And let's say 1, 2, 3, 4, 5, 6. 6 for x. And now we actually plug the triangle. This triangle is right angle, so with angle alpha, and when we calculate the gradient, right? So the gradient is changing y or changing x. So that's why we will have 2 minus, so this point will have 2 coordinates 2 and 0. So change in y becomes 2 minus 0 and 6 minus 2. So that's why the gradient becomes 2 over 4, or if you cancel this fraction, you'll get 1 over 2. Okay? So it means that how we can interpret the slope, right? We can say that for 2 units change in x, the function y value is changing for 1. Okay? So that's why it's less steep curve in comparison with identity line where y equals x. This is identity change. So for example, here the gradient is 1. So what does it mean if the gradient is 1? Change in y equals the change in x, right? So that's why they cancel. For example, for 1 change for x, we should have 1 or unit change in y. So that's why the gradient is 1. Okay, in our case, it's 1 over 2. So the fractional gradient tells you that it actually, the line is less steeper, all right? So if it's more steeper, so for this, we definitely can say that for this line, m is less, yeah, we can say that it's less than 1, all right? For line that goes in this manner, definitely m will be more than 1, because you can compare with the identity line y equals x, where the gradient is 1. All right. But sometimes you might see that in examples, or just you can imagine that the equation might look like minus 2x, let's say plus 1, all right? So what can you say about negative gradients? So negative gradient tells you, if the gradient is negative, it tells you that, for example, change in y should be negative when change in x is positive. What sort of line can represent? So the line corresponding to this equation with negative gradient should correspond to the line that goes in this way, all right? So basically, if you just run from the left to right, so your graph becomes falling. So it decreases in value when you move along positive direction for x, okay? So for example, if you take any 2 points, let's say this point, and let's say, I don't know, for example, this point, right? You see that change in value for y is negative because it's falling from point A to point B, okay? While change in x is positive. So this gradient should be negative. And actually it should be like negative 2 units when you move 1 unit for x, okay? So I hope it's clear. So visually you always can recognize that all those sort of lines should have positive gradients, and all these sort of lines here, here, or here should have negative gradient. Okay, so a great job has been done for this at this stage. So let's have a look. We actually only consider the first coefficient. Now it's time to find out something about C. All right, so let's do it here. And actually what we want to do, we want to say that we have sort of, let's say, sort of equation mx plus c, right? And we want to define the influence c on the line. So for this reason, I would like to present this line as the basic line, unit, so identity line, right? This one, so 1 to correspond to 1, okay? So, but we add some value c, okay? To this line, we want to add some value to c. So what does it mean? In terms of values, so let's say we can take for like simplicity c equals 2, and we just add 2. So what will happen if we construct the table again? We'll get for 0 and 1 for x, we'll get the following values. So 2 and 3. Before, for 0, 1, there was correspondency, like this new function, and that's the previous one. That was the correspondency like x equals to y, so that's why we had those values, right? But now we've got a new function y star that is just x plus 2, okay? And your values for y for the same axis different, right? So for 0 we have 2, and for 1 we have 3. So actually what happened to the line? It was shifted by actually 2 units up. You see, from 0 level, it was shifted 2 units up. So that's why, like visually, this C represents vertical shift. If it's positive, it means that the curve or the line goes 2 units up in comparison with the previous one, if you just consider only this part of the line. So if C is negative, it goes down, obviously, right? Assume we have x negative 2, x minus 2. So what it means that all the values for y now becomes basically negative, right? And that's why it means 2 units down. So new, like dotted line, was shifted down. However, you understand that both lines, no matter like where the shift occurs, they are parallel to our basic line, right? To our identity line. Why? Remember again, go back to m. So m defines the angle. So m is the gradient, the slope. Slope hasn't been changed. It's still 1x, right? So that's why it's only, so this c only has an influence on the shift, on the vertical shift, okay? So that's how you can describe. But actually, so if we clearly see m as basically a tangent of the line, where we can see c. All right, yeah, we understand that c is kind of shift, but what if we don't have any like basic line y equals x? How, for a given line, how to compare, how to consider c as what? Okay, so here is obvious point. One more time, mx plus c. So you understand that if we say that we take x equals 0, we're eligible to do that because we can take any x value for our line. So it means that we're here. So we can take any coordinates on y-axis, and any coordinates should have the first point, so the first coordinate x to be 0. Okay, so what it means that for our line that goes somehow, it will intersect y-axis. Y-axis is actually 0, right? It will intersect in some point A. And we know that x coordinates for this point is 0. So can we find out y coordinates for this point? Of course, yes. So we can plug x equals 0 in our equation, y equals mx plus c, so m times 0 plus c. And we found out that's 0, that y equals c. But in our case, y becomes y-intercept, right? So that's the same as y-intercept. And it's always be c, right? So that's why c determines y-intercept, okay? So that is designed for. It's designed to show clearly where y-intercepts. Okay, that means now we have the tool to describe like some random line. If you're given, for example, a line that goes through, let's say, points with the coordinates, let's say 2.5 for x, and let's say negative 1, we understand that we immediately can give an equation, right, from scratch. So we know this is c, i.e. y-intercept, so we determine this value, okay? And we also can determine the gradient, right? M. So let's remember, so m is changing y over changing x. So in our case, if we take change in y, it's from -1 to 0. So that's why change in y, it's rising, right? So ending point is 0, starting point is -1. So 0 minus -1 over, so let's see, change in x is from 0 to 2.5, right? So we have final point 2.5 minus 0, okay? So that's why m, in our case, minus -1 gives you +1. So 1 over 2.5. Okay, so it's not actually good numbers, so we can multiply both parts by 4. So we'll get 10, and here is 4. So we'll get 0.4 as decimal for m. So hence we define m and c, that is -1, all right? And we immediately can figure out the equation for this line, 0.4 m minus 1. Okay, very easy, and so that's really easy. Okay, so what other possible questions might be here connected with the lines? Okay, we actually seen that we can determine y-intercept. But what about x-intercept? How to determine it? So let's try to do it for this particular line. So for x-intercept, let's say this point, let's pretend that we don't know, that is 2.5, but we want to define using our equation. So, sorry, by the way, it should be 0.4x minus 1. Yeah, okay, because m was coefficient. So, how to determine x-intercept? You know that for y-intercept, we know that x is 0, right? But for x-intercept, we definitely know that the second y coordinate should be 0, because this line, I mean x-axis, and any point laying on this line should have y equals 0, because the level is 0 for y. Okay, so let's pretend we don't know this point. So we don't know. This is x-intercept. How to find this x-intercept? We just need to do the following. We know that for this point, y equals 0. So we plug y equals 0, and we have the following equation. So we have an equation for y-intercept, for x-intercept. So from where we can figure out x. So x becomes 1 over 0.4. If you just convert normally to decimal, it's going to be 10 over 4 or 2.5. All right. And indeed, we're actually seeing that it's 2.5. So one more time to recap. If we have y from x, and let's say this is the line, so c actually determines y-intercept. So x-intercept we can define by plugging 0 instead of y into general equation of the line. So mx+c. Okay, from here we can determine x-intercept generally as negative c over n. Okay, that's what stays for x-intercept. So actually now you have all tools in order to solve different sort of tasks. So about like positions and interrelations of two different lines. So like two lines to be parallel or two lines to be perpendicular. I'll create another video because this is a bit separate topic, and maybe an application for the line, for a straight line, for a linear equation. I also provide maybe in the next video. Yeah, I don't want to to create lots of video dedicated to straight lines because this topic is pretty easy, but for some reason it becomes confusing for students. Now I hope you understand how to work out the equation of the line and how to determine m and c. Alright, so this form for the straight line is well known as gradient-intercept form because it defines the gradient and c as y-intercept. So that's why it's called y-intercept, so gradient-intercept form. Okay, so you'll also probably might have a question about general equation of the line. Let's say x plus by equals d. So this is a general linear equation for a straight line, or general equation for general form for the line. But actually you can easily convert your gradient-intercept form into general form. So this is general form. So I'll tell you the last thing about straight lines. So what to do? For example, how to convert it. For example, you have the following equation: y equals, let's say 1 over 2x, let's say minus 1. All right. How to arrive to this general form? You just need to align all terms in this manner. Okay, so what to do? You notice that both x and y in one part in the left side. So that's why it's logically what you need to do. You need to transfer 1 over 2x here. So, and you will have y minus 1 over 2x equals negative 1. So, is it enough? So actually, yes. So the answer is yes, because look, and so better you can rewrite so that the first term should be ax. So in this manner. So why it's enough? Because you actually got this structure, right? You got this form. Because you from here you can say that a is 1 over 2 negative sign. So coefficient before y is b, it's just 1, right? And d is negative 1. But for some reason, sometimes of course you need to read carefully your word problem, your tasks dedicated to general form. So you need to probably have your a, b, and c, or and d positive, to be positive, all right? Positive, no, sorry, not positive, actually. To be integers, integers. So what does mean integers? Whole numbers, right? Positive, negative, or 0. So it means, for example, plus minus 1, plus minus 2, and so on. So that means, because here you have a fractional number, it's highly recommended to multiply by 2 in order the whole equation in order to get your whole coefficient or integers. So what will happen in this case if we multiply the whole formula by 2? We'll have the following. So minus x, because we multiply by 2, so plus 2y equals negative 2. That's okay. In this case, both, so all coefficients are integers. And d, let's say, is negative 2. Of course, they change the values, but you can create many multiple equations in general form, because, for example, you can multiply by 4, right, instead of 2, and you'll get negative 2x plus 4y equals negative 4. That's also equation for, in general form, for the straight line. The line is still the same. However, you just increase the value of each coefficient by 2, all right? So that's why this one and this one and this one and any other, because there are infinite ways to get the general form for your line, actually correct. But be careful about assignments. So probably A, B, and D should be integers. In this case, of course, this won't work because you have negative 1 over 2 for A, and this is a fractional number. It's not an integer. All right, so read just carefully and you'll see what you exactly need to do. Okay, so that's for now. That's all for now, and I hope you got this topic. So I'll try to do it in the simplest manner. However, you noticed that we went in depth. So hope you enjoy, and the next video will be dedicated to straight lines and different orientation of one line relating to the other lines. And so probably I'll pick up some problems dedicated to straight lines and we'll discuss. Okay, thanks for joining. See you.